Today we're talking about CCM6 factoring using the distributive property. So let's remember what distributing is. Distributing is when we have a number on the outside of the parentheses and some terms on the inside. And what that represents is this number is being multiplied by all the items inside the parentheses. So in this case we would multiply 3 times 2x. 3 times 2 is 6, so we have 6x. 3 times 5y, which is 15y. 3 times 4z, which is 12z. So that's just a little recap of the distributive property. Factoring is the distributive property, or distributing, in reverse. We will divide out a common factor from each term and get what's written in blue as our answer. So we'll be given, in a situation, what's written in pink here, and we'll have to undo the distributing, which is called factoring. Vic number 1, when you divide something by itself, you get 1 as your answer. That may seem like common sense, but when we do these problems, you'll notice it very often, seeing that, and you'll notice what it does to your answer. So our steps to factoring. First, we're going to find the GCF of the coefficients and the variables. We're going to place the GCF on the outside of the parentheses. So you'll have to create a new problem or a new expression with parentheses in it. Divide every term by the GCF. What is left over will remain inside the parentheses. For example, if you have the expression 14x minus 7y, out of these two terms the GCF is 7. So I'm going to divide out a 7 from each term. 14 divided by 7 is 2, and the x just kind of at this moment goes with that, 2. 7y divided by 7 is just 1. 7 divided by 7 is 1. So my GCF was 7, so I put it on the outside of my parentheses. And my 2x minus y was what was left over. 2x minus 1y. There's an imaginary 1 in front of this y, but you don't have to put it. It's imaginary. It's already understood that that's 1y. So let's try a couple. We've got very important concept number 2. Sometimes you will factor out numbers and or letters, which we call variables. Vic number 3, when you divide something out, you must divide it out of every single term that you have. So let's take this problem for example. 4d, take away 8h plus 6g. I've got, out of my numbers, I've got a 4, an 8, and a 6. Well, I know that a common factor between 4 and 8 is 4, but that is not common with the number 6, so I can't use it. The greatest common factor between these three terms, these three numbers, is 2. So I'm going to actually pull out a 2, and I'm going to now figure out what's remaining inside my parentheses. So 4d divided by 2 is 2d. 8h divided by 2 is 4h. 6g divided by 2 is 3g. What remains is equivalent to what we started with. I just simplified it a little bit more. Let's try this one. 12vz plus 16wz. Well, I noticed that they have 4 in common. So the greatest common factor of 12 and 16 is 4. So I'm going to pull that out. But if I look at the letters, I notice that they both have a z in common. So that's going to be my other factor, common factor that I pull out from both items. So 12vz divided by a 4 and a z is just 3v. Because z divided by z is 1. That was that important concept we talked about. 12 divided by 4 is 3. And then, well, the v, there's nothing to divide the v out, so it stays inside the parentheses. 16 divided by 4 is 4. There's nothing to divide that w out, so we leave it. Z divided by z is 1. I don't need to report the 1, so this is my final answer. Okay? Let's look at an area model to help us maybe understand this concept just in a different way. It says fill in the missing dimensions from the expression given. So I've got 5x plus 35, and I've got, what I would do here is I would fill in this 5x plus 35 in my model. So I'm asking myself, if this was the answer to an area problem of a rectangle, what length and what width do I have to multiply together that gives me this answer as a result? So again, it's like working backwards. So if I have 5x in here and 35 in here, what times what gives me 5x? And then what times a different number gives me 35? Well, if I pull out a 5 here, if I'm pulling that out from this entire row, pulling out as in dividing, 5x divided by 5, the only thing that would have to go here is x. So if I multiplied this row and this column together, 5 times x, that would be 5x. So that's my product of this item and this item. Well, I've already got 5 written here, so the only number that I can multiply by 5 to give me 35 would be 7. So that's got to be what goes inside the parentheses, and that's got to be what stayed on the outside. So this, what I wrote in pink, is the factored version of this expression. Why don't you try this one on your own? Pause the video, write this here in this box, and think to yourself, what can you divide out or pull out to give you this as a result? Okay, good luck. Is this what you got? So I pulled out a 9 because I knew 9x and 81 both had 9 in common. So I pulled it out and I said, what times 9 gives me 9x? Well, x times 9 has to give me 9x. Then I say, okay, same thing, but for 81. What times 9 gives me 81? 9 times 9 gives me 81. So here's my final answer using the area model. Let's try another model, slightly different. This is the Venn diagram model. So here I've got an expression, and I'm still doing the same thing as before. I've got my Venn diagram, circles. As you see here, I made the prime factorization of 24. I did the prime factorization of 15. Now the final step is in the middle here, write what they have in common, and then on the outer rim of my Venn diagram, put what they don't have in common. So let's start with the numbers first. 24 and 15. Looks like they both have a 3 in common, and that's it. So I used their 3's already, and now let's just write the remaining factors they have in common. That they don't have in common. 2, 2, and 2, and then 5 is what's left over. That's just the numbers. Let's look at the variables. Okay, they both have an x in common, so I'm going to put that on the inside. So guess what? In this Venn diagram, I take what they have in common and I put it outside the parentheses. What remains is what's on this side of the Venn diagram, but I multiply them. So 2 times 2 times 2 is 8, plus 5 is left over. All done. Why don't you take a shot at this one, pause the video, and then when you're ready, just push play, and I'll finish it out. Okay, so I've got 5, and that's prime, but I have 5 here also, so they have a 5 in common. This one is just y. This one's got a 2, 2, and 2, and a w. So they just have a 5 in common. Left over would be y plus 2 times 2 times 2 is 8, and a w. That's it. That's the answer. Well, I showed you 3 different ways of factoring, and I hope you caught on. Have a great day.